Welcome back. This is another video on limits. This time, I'll discuss one-sided limits. Let me give you a theorem first. This is a very important theorem in limits, so let me just read it. The limit of f of x as x approaches a exists and is equal to L if and only if the limit of f of x as x approaches a from the right and the limit of f of x as x approaches a from the left both exist and are equal to L. So if a here over here has a plus sign that is a subscript to it, a superscript to it, then we read this expression as the limit of f of x as x approaches a from the right. Now, if a has a superscript that looks like a negative sign, so we read the expression the limit of f of x as x approaches a from the left. So it's like the limit of f of x as x approaches a is equal to L if and only if this happens. The limit of f of x as x approaches a from the right is equal to L, exists and is equal to L, and also the limit of f of x as x approaches a from the left is also equal to L. Okay? You see, if we have the function, so let's consider the function f of x equals square root of x. The graph of that function would look like this. So it's passing through, it's actually half of a parabola opening to the right with vertex at the origin. So here, and then another one. Okay, let me get another point when x is 4. The value of the function is 2. So it's like that. So that's connecting the points. We'll get this graph. So it's half of the parabola opening to the right vertex at the origin. Alright, it's like that. Okay, remember that the limit of the function as x approaches a is actually the behavior of the function as x goes closer and closer to a from both sides of the function. Now, if I take the limit of, if I want the limit of the function f of x, which is equal to square root of x as x approaches 0, okay, then I have to take the limit of the function as x approaches 0 from the right, and also the limit of the same function as x approaches 0 from the left. Now, if these two are equal to the same number, they both exist and they are equal to the same number, then we can conclude that this is also existing and is equal to the same number also. Okay? Now, if we try to look at the graph, as x approaches 0 from the right, look at how the function behaves. It goes there to that point. And at that point, the value of the function is 0. Okay? So it goes to the function 0. Now, as x approaches 0 from the left, look at this. There is no graph. There is no graph on the left side of the y-axis. So actually, the left side of the y-axis is not included in the graph, is not included in the picture. Okay? So it means to say that as x approaches 0 from the left, there is no graph. So there is no behavior. Okay? Because in the first place, there is no graph on the left side of 0. So in that case, the limit of square root of x as x approaches 0 from the left does not exist. Okay, this does not exist. Okay, DNE stands for does not exist. While the limit of square root of x as x approaches 0 from the right is simply square root of 0, where it is equal to 0. Okay, so one of them does not exist. This does not exist. The other one exists and is equal to 0. They are not equal to each other. And so we also say that the limit of square root of x as x approaches 0 does not exist. Okay? Because this only exists if these two are equal to the same real number. Alright? So that's by the graph. So what happened to the concept that we just substitute a for x? Why can't we just solve this by substituting, so let's say limit of x as x approaches 0 by substituting 0 for x, and that we get 0. Okay? So take note, if we do that, your answer will be incorrect or wrong. Because if we try to identify the domain of the function, the domain is actually a set of non-negative real numbers. So it starts from 0 up to any positive number. So from 0 to positive infinity. So therefore, remember that here x is just approaching 0 and x is not actually exactly equal to 0. Therefore, from the left side, so for this one, as x approaches 0 from the left, the numbers that are on the left side of 0 are the negative numbers. And as we know, the negative numbers are not included in the domain. So, it means to say that there are no numbers to substitute for x here in the limit of square root of x as x approaches 0 from the left. Another example that is quite similar to the first one that I've given in the previous slide. So this one. Okay. Remember that the domain of the function is actually f of x equals square root of x minus 4. Okay, you cannot substitute any number less than 4 for x in the radicand, right? So therefore, if x is approaching 4 from the right, then we are actually substituting not the exact number 4, but a number very, very close to 4, but on the right of 4. It means to say that we are actually substituting a number greater than 4 here. So it's okay, we can do that, right? So how do we evaluate the limit? Substitute 4 for x minus 4, and that's equal to square root of 0. And so square root of 0 is 0. That is the limit of square root of x minus 4 as x approaches 4 from the right. Okay, this is our answer in number 1. Remember, when we substituted this number 4, we are actually not substituting exactly 4, but a number very, very close to 4. Let's say 4.000001. Okay, so 4.000001 minus 4 is almost a 0. Hence, we're taking this as our answer. On the other hand, if we'll take the limit of the same function, x minus 4, as x approaches 4 from the left this time, and we know that any number that is coming from the left of 4 is less than 4. And in this function, we cannot substitute a number that is less than 4. Okay, otherwise the function will be undefined. So what do we say that our answer is? In number 2, the limit of the function square root of x minus 4 as x approaches 4 from the left does not exist. Alright? Simply because we cannot substitute a number that is less than 4 for x in the given function. Alright, we take another example. The limit of square root of x minus 2 over square root of x squared minus 4 as x approaches 2 from the right. Okay. Now, since we are allowed to substitute a number, remember that this means x is approaching 2 from the right, means that x is a number very, very close to 2, but on the right of 2. So it's actually a number greater than 2. So we can substitute any number greater than 2 here for x in our function. So we can just, to evaluate the limit, we can just substitute. And we get 2, sorry, minus 2 over square root of 2 squared minus 4, and that's the square root of 0 is 0 over 0. So what do? We have, if we get the indeterminate form, then we have to do something with the function. Now what can we do with the function? Limit of x minus square root of x minus 2 over square root of x squared minus 4 as x approaches 2 from the right. What can we do? We can actually factor the denominator. Okay, factoring the denominator, the radicand in the denominator rather. So the square root of x minus 2 over the square root of the factors of x squared minus 4 or x plus 2x minus 2. I hope you remember this formula. And then of course we can write everything inside one radical sign, where the numerator is x minus 2 and the denominator is x plus 2, x minus 2. And then simplifying the radicand by dividing x minus 2 by itself. So now we'll have the limit of square root of 1 over x plus 2 as x approaches 2 from the right. Okay, now evaluate the limits by substituting 2 for x in the function. So that's square root of 1 over 2 plus 2. Remember, we are not actually substituting 2 for x, but a number very, very close to 2. Okay, so approximately it's equal to 2. So the square root of 1/4, and square root of 1/4, as we know of, is 1/2. So this is the limit of square root of x minus 2 over square root of x squared minus 4 as x approaches 2 from the right. Okay. Now I think you already know that when we take the limit of the same function, square root of x minus 2 over square root of x squared minus 4 as x approaches 2 from the left does not exist. Why? Just because the number x approaching 2 from the left side of 2 is actually a number very, very close to 2, but on the left side of 2, so it must be a number less than 2. So if we substitute here and here a number that is less than 2, what happens to the radicand? They become negative numbers, alright? And so if the radicands are both negative in the numerator and denominator, while the indices of the radicand or the radical are both even numbers, so we'll get a complex number which is actually undefined in the set of real numbers. Therefore, this is the answer. Okay. Now for the next example, I will give you a piecewise function. So f of x is defined by x squared minus 4 if x is less than 2, 4 if x is exactly 2, and then 4 minus x squared if x is greater than 2. Okay, so we want the limit, so find the limit of the function f of x as x approaches 2 from the right, and b the limit of the function f of x as x approaches 2 from the left. And upon getting that, you'll be able to conclude whether the limit of f of x as x approaches 2 exists or not. Okay, so let us solve letter A. Letter A, limit of f of x as x approaches 2 from the right. You see that f of x is defined by 3 expressions. So which of the 3 expressions do we choose? Okay, we evaluate the limit of which of the 3 expressions. Is it the limit of x squared minus 4, or the limit of 4, Or is it the limit of 4 minus x squared? So as x approaches 2 from the right. Remember that numbers that are on the right side of 2, because of this, 2 is approaching, x is approaching 2 from the right. So it means to say that we are actually taking numbers or substituting numbers that is greater than 2, okay, in the function. So looking at the conditions, if x is greater than 2, look at this, we take this expression. So therefore, evaluate the limit of 4 minus x squared when x is approaching 2 from the right. Just because we take this function, the third one, if x is greater than 2. Okay? So now we evaluate by substitution. So it's now 4 minus 2 squared. So what do we get? It's a0. So this is the limit of f of x as x approaches 2 from the right. Alright. Now what is the limit for letter B, limit of the function as x approaches 2 from the left? Okay. When x approaches 2 from the left of 2, then x must be a number less than 2, right? So if we try to look at the conditions, when x is less than 2, we take this expression. Therefore, when x approaches 2 from the left, we find the limit of the first function. Okay, as x approaches 2 from the left. Now substituting 2 for x, we get 2 squared minus 4. That's also giving us a 0. So the limit of f of x as x approaches 2 from the left is equal to 0. Now that a and b are both existing, so they both exist, and they are both equal to the same number, then we can conclude that the limit of f of x as x approaches 2 is also existing and is also equal to 0, because these two are equal to the same number. One last example, give you g of x defined by two expressions, x squared plus 2 and then 2x squared plus 2. First one is if x is less than or equal to 1. We use the second one if x is greater than 1. Okay, so we evaluate, we find the limit of g of x as x approaches 1 from the right, also the limit of g of x as x approaches 1 from the left, and finally the limit of g of x as x approaches 1. Okay? Solving letter A, the limit of g of x as x approaches 1 from the right. Again, when x approaches 1 from the right, we have x is a number greater than 1, right? So we take this condition, and so when we want to evaluate the limit of g of x as x approaches 1 from the right, we take the second expression, 2x squared plus 2 as x approaches 1 from the right. So that's going to give us 2 times 1 squared, substituting a for x, right? So that's a 4. This is the limit of g of x as x approaches 1 from the right. What about when we want to answer letter B? The limit of g of x as x approaches 1 from the left. If x approaches 1 from the left, then x must be a number less than 1. So the numbers less than 1 are in this set. So if we want the limit of g of x as x approaches 1 from the left, we use the first expression, plus 2. So substituting 1 for x, we'll have 1 squared plus 2. And that's equal to 3. This is the limit of g of x as x approaches 1 from the left. Now for letter C, although The limit of g of x as x approaches 1 from the right exists, and also the limit of g of x as x approaches 1 from the left exists also, but they are not equal to the same number. This is equal to 4, this is equal to 3. So therefore, the limit of g of x as x approaches 1 does not exist. Okay?